All right, let's go through numbers 13 through 15. And these free response questions were actual AP free response questions for you. So I want to make sure that I don't skimp over those. All right, so see here we have this problem with the flu vaccine shortage in the United States. It was believed that 45% of people eligible received the flu vaccine. And then they did a sample. And that random sample of 2350 indicated 978 of them had received the flu vaccine. So make a 99% confidence interval. Use your confidence interval to comment on the belief that 45% of the vaccine eligible people had received that flu vaccine. So after I make my interval, I'm going to be interested in if this 45% is in my interval or not. Okay, so this is due a panic. So don't forget your P equals the proportion of vaccine eligible people who have received, present tense, the flu vaccine. Random. This was stated that we had 2350 randomly selected vaccine eligible people. That's who was in my sample. And that 2350 is certainly less than 10% of all vaccine eligible people in the United States. Large enough. We don't have a true P. So we use, we're going to later compare 45% to it, but we always are using then when we have this our P hat because we don't know what it is. So we have our successes, which is greater than or equal to 10, and then the failures, which is greater than or equal to 10. So the approximately normal model applies. This is a 1 proportion Z interval. So now let's go ahead and make this interval. So, okay, here is this formula. Now, this is on the formula chart. Your statistic, that is your P hat, okay? Plus or minus your critical value, that's your Z star. And see, that right here comes from you being 99% confident. So here on the AP exam, they did 99% confident. That puts 1% split. So that's a half of a percent here in one tail. So you had to do inverse norm of 0.005. That's 2.58 for that critical value. Okay? Then this standard error is your standard deviation for proportions. You do in the p hat, 1 minus p hat over n. So that's what I got right here. And then see, I had this p hat was 0.42. Okay. So 0.0102. All right. So that's how I got that. Then I did the subtraction and the addition. So I got this 0.394 and up to 0.446. So 0.446, if you just left it at 0.446, which on AP I probably would have, because especially since they're interested in 45%. Yikes, that is just really right there on the cusp of being in there or not. So, man, you've just really got to be. That's why I kept all 3 of these decimals here. But anyway, so suppose you had rounded it to 2 significant figures, like I have told you, and you said from 0.39 to 0.45, then I'm 95% confident the true proportion of vaccine eligible people who got the flu vaccine is that. But I comment on this. I say, according to my interval, 45% is a plausible value. Could happen. I'm not saying it is. But had you done an interval that did not include it, so note, if you had made an interval that did not include, if your rounding did not contain 45%, you would be expected to say, that according to your interval, the estimate of 45% is too high because it probably would have been on the above it for the true proportion of vaccine eligible people who have received the flu shot. Okay? In part B on this problem, we are asked to what is the smallest sample size you can have to guarantee to have a margin of error less than or equal to 0.02. So you have to come up with this. This is on your own, knowing that the margin of error on a confidence interval is the critical value times that standard deviation. So to be 99% confident, so I kept that there. Here is my 0.02. Now, so I think I went up here. Suppose a similar survey will be given to vaccine eligible people in Canada by Canadian health officials. Um, I'm thinking that it did not tell me to use the American estimate or anything. So I probably would have written this out on the AP exam so that they knew why I chose 0.5 here instead of this 0.42. See, that was the American estimate. So I wrote here, I suppose that since we are not given an estimate of the p hat to start with, we're going to use a p hat of 0.5. Okay, so there you go. So that's what I did. I came up with 4,161 people they need to sample to have that level of accuracy. All right, so there's number 13. So here comes 14. This was a big question item in class today. So here we go. What is the critical value? So the question is asking, what is the Z star based on those situations? And the alpha is going to be 0.12, okay, in all situations. So the key to doing this problem is examining the alternative hypothesis. This alternative hypothesis says it is a one tail, upper tail. We're interested in putting the entire rejection region in the top tail. So that's the top 12%. So if that's the top 12%, then here I do my little inverse norm of the lower 88%, and that's how I get that critical value of 1.17. Part B has a different HA. It has an HA that is a one tail, lower tail. So it puts the entire 12% in this lower section. So I inverse norm that 0.12. So that one's critical value is negative 1.17. But look at the third part C. This one is a two-tailed alternative because it's a not equal to. So that one takes the rejection region of 12% and splits it between the two tails. So that's got 0.06 in both tails. So my critical value is inverse norm of 0.06. So I've got that negative 1.55 and that positive 1.55. All right. Now, very, very important thing here that you need to know for number 15. So let's take a look at this. A 90% confidence interval for the proportion of cheese purchases is this number right here. Okay? If the store owner claims that 86% of the cheese sales are cheddar, run a significance test at that 5% level, what would you expect? So what I need to do is compare this 0.86 claim to the interval that I got. And because this HO is not in the interval, the interval is entirely below 0.86, then I think that the proportion of cheddar cheese sales is actually lower than 0.86. So since I think that it is lower than 0.86, I would end up rejecting because our null hypothesis would say P is 0.86, and of course our alternative, is, I guess, this less than, because I think that it's entirely below. All right. And then I will I think I did 13, 14, 15. So we'll start on number 16 and do 16 through 18 in the next video. All right, I hope that made sense for you.